This is SpaceTime, Series 23, Episode 12. Coming up on SpaceTime, NASA working to try and save the Voyager 2 spacecraft. The European Space Agency's solar orbiter ready to launch on its mission to the Sun. And the most detailed high-resolution images ever taken of the surface of the Sun. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, are working to try and restore systems after all 5 of Voyager 2's science instruments suddenly stopped working. The shutdown by the probe's fault protection systems routines was triggered by a mysterious energy spike. Engineers don't know what caused the sudden increase in power consumption, and they're working to try and get the spacecraft back into normal operations. Voyager 2 is now in interstellar space, some 19.5 billion kilometers from Earth. It's the second most distant man-made object in existence, beaten only by its twin Voyager 1. Apparently, the incident happened as Voyager 2 was scheduled to undertake a 360-degree rotation. That's designed to help calibrate the probe's magnetometer, an instrument used to measure magnetic fields. For some unknown reason, the spacecraft delayed the maneuver, leaving 2 of its systems running at high power, and that triggered onboard software to offset the power deficit by shutting down its 5 operational science instruments. Mission managers have now shut down one of the 2 power-hungry systems, allowing them to turn the science instruments back on. But the spacecraft is still not cleared for normal operations, and it's not collecting any new data, at least for now. Voyager 2 was launched from the Cape Canaveral Air Force Station in Florida way back in 1977, just 16 days before its twin Voyager 1, on a trajectory that took longer to reach Jupiter and Saturn, but enabled Voyager 2 to also have encounters with 2 additional planets, the ice giants Uranus and Neptune, thereby giving the spacecraft the grand tour of our solar system. In 2018, the probe crossed the heliopause at a distance of 16.58 light-hours, leaving the solar system and formally entering interstellar space. The heliosphere is the bubble created by the Sun's atmosphere, which engulfs the entire solar system. After 42 years of continuous operations, both Voyager spacecraft are having their power consumption carefully managed. The probes are powered by radioisotope thermoelectric generators, or RTGs. These use heat created by the radioactive decay of plutonium-238 to produce electrical power. Mind you, the Voyagers are nearing the ends of their operational lives anyway. That's because their RTGs are only expected to last another 5 years or so before the plutonium-238 can no longer provide enough heat to power each spacecraft's instruments. You're listening to SpaceTime. Coming up next, the European Space Agency's solar orbiter ready for launch on its mission to study the Sun. And later in the science report, researchers have released the Kraken, or at least its genetic code. All that and much more still to come on SpaceTime. Well, it looks like it's all systems go for this month's launch of the European Space Agency's solar orbiter mission to the Sun. The 7-year mission will undertake detailed measurements of the inner heliosphere, a nascent solar wind, and the first ever direct images of the Sun's polar regions. The 1,800-kilogram spacecraft will fly aboard an Atlas V 411 rocket from Space Launch Complex 41 at Cape Canaveral. It'll fly on an eccentric elliptical orbit, moving as close as 42 million kilometers to the Sun. That's closer than the orbit of Mercury. But the probe will take some 3.5 years, using repeated gravitational assists of Venus and the Earth in order to reach its operational orbit. And there'll be further gravity assists from Venus to raise its orbital inclination to about 25 degrees above the ecliptic, the orbital plane of the Earth around the Sun. And if all things go well and the mission's extended, that inclination will eventually be increased to 34 degrees. Solar Orbiter is carrying 10 science instruments for imaging the surface of our local star and for measuring the properties of the environment in its vicinity. The probe's instruments will peek at the Sun through tiny windows in a 30-centimeter thick titanium heat shield. That's designed to protect the spacecraft against the soaring temperatures and the constant bombardment of highly charged particles in the solar wind. The spacecraft will make close approaches to the Sun every 5 months, observing the buildup of magnetic activity in the solar atmosphere, which can lead to the eruption of powerful solar flares and even more powerful coronal mass ejections. Solar Orbiter scientists will also coordinate their observations with those of NASA's Parker Solar Probe mission, which is performing measurements of the Sun's extended corona. Solar Orbiter's high-resolution studies of the Sun and its inner heliosphere will provide scientists with a new understanding of how and where the solar wind plasma and magnetic field originate in the corona. It'll also study how solar transients drive heliospheric variability, how solar eruptions produce the energetic particle radiation that fills the heliosphere, and how the solar dynamo works and drives connections between the Sun and the heliosphere. To do all this, the probe is carrying a multitude of instruments, including a solar wind analyzer to measure the solar wind's properties and composition, an energetic particle detector to measure superthermal ions, electrons, neutral atoms, and energetic particles, a magnetometer to study the Sun's magnetic field, a radio and plasma wave analyzer to measure magnetic and electric fields at high time resolution, a polarimetric and helioseismic imager to provide high-resolution and full disk measurements of the photospheric magnetic field, a full sun and high-resolution imager to observe different layers of the solar atmosphere, a spectral imager to gather data on the photosphere and corona and to characterize plasma properties, a spectrometer telescope to image thermal and non-thermal solar X-ray emissions, a coronagraph to provide simultaneous ultraviolet and polarized visible light imaging of the corona, and a heliospheric imager to study quasi-steady and transient flows of the solar wind. Meanwhile, mission managers at the European Space Agency's Operations Centre in Darmstadt, Germany, have been spending months on simulations of Solar Orbiter's first moments in orbit, and they've also been doing simulations of the delicate manoeuvres needed during the journey that will make Solar Orbiter's mission possible. This report from ESA TV.
When ESA's Solar Orbiter launches from Cape Canaveral on an Atlas V rocket, its mission team will be more than ready. They will be ready for anything. At the European Space Operations Centre in Darmstadt, Germany, crucial parts of the spacecraft's journey have been rehearsed over a period of 5 months inside the main control room. This mission simulation is the final one before the dress rehearsal and the launch itself. 2 teams in 8-hour shifts take turns to provide spacecraft control from launch onwards around the clock. But the simulation is deliberately designed to not always go like clockwork, as problems and last-minute changes will be introduced to ensure that the team will be prepared for anything, no matter how unexpected.
So failures range from spacecraft issues. For example, after separation, you don't have the signal from the spacecraft, or failures on board of prime units. We have to be ready to react. Down to we have to make sure that all our ground systems are ready to for us to be able to control the spacecraft, so we can get control system errors on ground or antenna issues, so the antenna which allow us to talk to the spacecraft. We can also have sick people as failures, so we need to be able to react to any contingency. Or, for example, to evacuate the main control room in case of whatever issue. We have a backup room in another building here. So all these things are trained and sometimes all together at the same time, so it gets quite interesting.
Today's simulation rehearsed the first day of the mission from the separation from the launcher onwards. The trajectory required to get from the Earth to observe the Sun has been designed and optimized by the mission analysts. Solar Orbiter will use a ballistic trajectory, which means directing its orbit by using gravity assists.
A gravity assist is flying by very close to a planet in order to use the gravitational pull of this planet to change the orbit. This we do repeatedly with Venus 7 times and with the Earth 1 time. By doing so, we can finally achieve an orbit that is elliptic, gets close to the Sun, and that goes out of the ecliptic. The ecliptic is the plane in which all the planets are orbiting the Sun. And by going out of the ecliptic, we get to high latitudes and we can get very clear observations of the Sun poles.
These high latitudes mean Solar Orbiter will provide the first images of the Sun's poles, as well as investigating the heliosphere and the solar wind. And these simulations play an important role in ensuring that not only will its team be mission ready, but that Solar Orbiter and its science will be a success.
And that report by ESA TV included Solar Orbiter Spacecraft Operations Manager Sylvian Loddett and Solar Orbiter Mission Analyst Jose Manuel Sanchez Perez. You're listening to SpaceTime. Still to come, the most detailed high-resolution images ever taken of the Sun's surface, and a new study of alien invasion. And in this case, it looks like we're the aliens. All that and more still to come on SpaceTime. Astronomers have released the most detailed high-resolution images ever taken of the surface of the Sun. The amazing images taken by the National Science Foundation's yet-to-be-completed solar telescope in Hawaii show cell-like structures as big as the states of New South Wales or Texas rolling on the Sun's photosphere or visible surface, and footprints of magnetism reaching deep out into space. Professor Jeff Kuhn from the University of Hawaii says the unprecedented detail of these images demonstrates the sheer power of the new ground-based telescope to map magnetic fields in the Sun's corona, where solar eruptions which impact life on Earth are generated. These space weather events can disrupt air travel, cause power blackouts, disable communications and navigation systems, and destroy or damage spacecraft. Kuhn describes the new technology which allowed the images to be taken as the greatest leap in humanity's ability to study the Sun from the ground since Galileo's time. And the new 4-metre telescope will become even more powerful as an additional suite of state-of-the-art instruments come online in coming months. Scientists have constructed 2 complex infrared instruments designed to ultimately allow researchers to predict the Sun's magnetic field activity and solar storms. The first is called the Cryogenic Near-Infrared Spectropolarimeter. This 2-ton instrument is designed to measure the Sun's magnetism beyond the visible solar disk. The second instrument, called the Diffraction-Limited Near-Infrared Spectropolarimeter, will allow scientists to view the evolution of the Sun's magnetic fields in extreme detail. Both instruments use sensitive infrared technology and complex optics that reveal sunspots and small magnetic features and how their magnetism reaches into space. The new solar observatory, which stands on the summit of the 3,000-metre high Haleakala volcano on the island of Maui, is by far the world's largest and most powerful solar telescope. By the way, Haleakala, well, it literally means House of the Sun. While the solar telescope isn't set to be completed until June, scientists will continue doing preliminary tests, making observations of the Sun over the coming months. Of course, pointing any telescope directly at the scalding sphere of the Sun comes with challenges. The Sun's sweltering surface temperature is around 6,000 degrees Celsius. And so a specialized cooling system has been put in place at the telescope to protect its delicate instruments from this massive amount of heat. In fact, the focus of the telescope mirror would be hot enough to melt metal within a really short period of time. So to deal with these heat challenges, scientists need to produce the equivalent of a swimming pool's worth of ice every night to provide cooling for the optics and structure during the day, with more than 11 kilometres of piping distributing coolant throughout the observatory. You're listening to SpaceTime. Still to come, SpaceX launches its 4th batch of 60 Starlink satellites, and later in the science report, a new cell phone that sweats to keep cool. All that and much more still to come on SpaceTime. Science fiction writers often portray alien invasions attacking Earth and humanity, and there is a strongly held hypothesis known as panspermia, which suggests that microbes could be transported from one world to another as hitchhikers inside asteroids, comets and meteors. Now, under this scenario, life on Earth, which began about 4 billion years ago, may have been seeded through meteor impacts from elsewhere in the solar system or beyond. For example, Mars and the Earth have been swapping rocks through meteor impacts for billions of years. Importantly, the Earth was still uninhabitable at a time in the early solar system's history when Mars was already a warm, wet world with a thick atmosphere which would have been capable of sustaining life. So, a meteor impact on Mars back then could have thrown ejector-containing microbes into space, which would eventually, after millions of years of floating in space, reach the Earth at a time when our planet was more habitable. In other words, there's a possibility that we really could all be Martians. Now, if panspermia is true, then it means the universe could be teeming with life, just waiting to land on a habitable planet where it could get started. Now, were that the case, then any life found elsewhere would have a similar genetic basis and chirality or handedness to life here on Earth. In fact, that would be one of the tests for panspermia. Mind you, that could also imply that life might only ever have been created the once, and simply spread from that one beginning. On the other hand, if we eventually find life and it's totally different from what we see here on Earth, for example, it might be based on silicon rather than carbon, then that would imply that life has been created more than once, and that's a prospect with endless possibilities. But while the idea of multiple life-creating events is fascinating, it's still all hypothetical. On the other hand, what we do know for fact is that there's a strong likelihood that humans have already contributed to panspermia. See, no matter how clean they are, spacecraft being sent to other worlds often carry hitchhiking bacteria. In fact, that's why NASA and the European Space Agency have a policy of deliberately destroying probes at the end of their missions, rather than risking the probes crashing onto and contaminating worlds which have the potential to support life. And then there's the 2 Voyager probes which have now left our solar system. As well as carrying information about Earth's life with them on plaques and golden records, they most likely have also inadvertently carried samples. And it's not just man-made objects. Life from Earth could have spread beyond aboard comets and asteroids that skim the planet's atmosphere during their journey, picking up microbial hitchhikers. Studies have found microorganisms existing at altitudes of 50 kilometers above the Earth's surface. And one study, although not repeated, has even detected them as high as 77 kilometers above the Earth's surface. In fact, some scientists think it's possible that microbial life has simply been blown into space from the upper atmosphere. And that's what Harvard theoretical physicist Avi Loeb and colleagues are considering in a new study they've published in the International Journal of Astrobiology. Their research suggests that long-period comets, these are comets originating in the Oort cloud, as well as interstellar objects like Oumuamua and Borisov, could have potentially hit an atmospheric sweet spot, allowing them to carry microorganisms from Earth into interstellar space. According to their calculations, as many as 50 interstellar objects could have flown by the Earth over our planet's lifetime before leaving the solar system for good. And up to 10 long-period comets, freed by the gravitational pull of passing stars, could also have escaped with life. Mind you, hitchhiking a ride is only the start for microbial life trying to escape Earth. Once you're out there, beyond the protection of the atmosphere, there's all the radiation and cosmic rays you have to deal with. And that's why comets would make really good transports. Their icy surfaces are extremely porous, allowing microbes to burrow or be pushed down below the surface where they'd be shielded from harmful radiation. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Now, Fred, we are going to talk about a topic of great interest, of much speculation, and that is the movement of life throughout the solar system and the galaxy, maybe the universe. We're probably getting a bit stretchy there, but we've always thought, or there's been theories, that life was came about on Earth as the result of something seeding the planet. But what if it's the other way around? Life started here and we are seeding everywhere else. Wouldn't that be a turn up for the books?
It would indeed. And the person who's put that forward was not in the least surprised to see his name attached to this paper. Harvard University astronomer Avi Loeb, he's the director of the Harvard Center for Astrophysics, with his colleague Amir Siraj. They have put forward a paper that draws attention to the possibility that exactly what you've described might have happened, that living organisms on the Earth may have been picked up by passing interstellar asteroids, and we now know that these things exist because we've had visits from them.
The space doogie.
Yeah, that's right. Picked up by things like that and carried to other solar systems, or, as you say, even beyond the realms of the galaxy. So the story really goes back to the 1970s when Fred Hoyle, a very great British astronomer, sadly no longer with us, and Chandra Wickramasinghe, who was one of his PhD students, now I believe at the University of Buckingham. He spent a long time at the University of Cardiff, but is now in Buckingham. And I actually, many years ago in my career, I heard Fred Hoyle speaking about this really interesting talk. They proposed the idea that the reason why we have life on Earth is that, exactly as you said, that it was seeded from space. So microbes actually arriving some means or another, perhaps by meteorites and things of that sort. And we talked recently about the Murchison meteorite, which is full of organic material. So the Hoyle and Wickramasinghe suggestion was that perhaps that sort of organic material was what gave rise to life on Earth. And actually, there was a very prominent and really expansive paper came out on this last year that elaborated on this possibility. And it talked about, there is something, I think it's called the Cambrian explosion, was suggested by Chandra Wickramasinghe, because I think this suggestion was made after Fred's death. But the idea was that this explosion of life was caused by stuff coming from outer space. In other words, it wasn't just a result of life rapidly evolving on Earth, that stuff came from outer space and we got this huge level of diversity on Earth.
They're suggesting the time frame between 541 and 530 million years ago.
Yes, that's right. That rings an absolute bell. It's something like that, of order 500 million years. Yeah. So, that's put in a framework of the idea that we on Earth received living organisms from outer space. But this turns it on its head and says, well, yes, that might have happened, but the opposite could have happened as well. And so what Amir Siraj and Avi Loeb have done is they have looked at basically modelled the possibility that microbes in the atmosphere of the Earth could have been transferred to anything like a comet or an asteroid passing through from another solar system that had a close encounter with the Earth. We know, for example, that there are colonies of microbes in the atmosphere as high as 77 kilometres from the surface. Now, that's not very far from the edge of space at 100 kilometres away. So, and we know already that microbes exist, can survive on the outside of the International Space Station. So the idea that microbes could exist in the upper atmosphere and perhaps be transferred to a passing object, they've modelled this possibility, and sure enough, they say certain speeds and particular angles, both comets and asteroids could actually graze the upper atmosphere and collect stuff. And it may well be that the Earth has spread microbial life throughout the solar system and beyond.
And the smoking gun will be us discovering microbial life elsewhere and discovering that it is of the same making.
Yeah, exactly. That's right.
That won't suggest absolutely that it came from here, but
no,
it will suggest that it did come from the same source, wherever that may be.
Wherever it was, that's right. So if we find, if we get to DNA sequence things on Mars and find that they've got the same genetic ancestry as life on Earth has, you don't really know whether this stuff's come from Mars or this stuff's come from Earth. But what you do know, as you've just said, is that it has a common source. It's a really interesting piece of work.
We had a near miss, I will call it, some years ago, I think during the Clinton administration, where they found a rock and it had fossilised microbes on it, as far as I remember, and they initially thought it came from Mars.
Yes, that's right. Well, it does come from Mars. That's the ALH
microbes.
84001, I think it's called, meteorite. So it's definitely come from Mars, but the dispute is not whether it comes from Mars, it's whether the features, the microscopic features that were found on it actually have a biological origin. And the consensus among scientists is that they're actually chemical rather than biological. Many times we've been warned against seeing things that look like living organisms or fossilized living organisms and actually saying, well, they look like it, so that must be what it is. And, I think you and I spoke last year about
Ethiopia.
That's right. Yes, exactly that some things that were found in the lake in Ethiopia have a chemical origin. And in fact, I think I mentioned during that conversation, I've been talking to an astrobiologist formerly in the United States, but now in Italy, who sent me a reference to a book published in, I think it was 1914, it was the early part of the 20th century, which is full of pictures of chemical gardens, things that pure chemistry, but look for all the world like living plants. Really interesting stuff. And so you just can't say, well, it looks like it, therefore it is it. There has to be much more to it than that. Nevertheless, all that is very interesting. And I think that all the studies that Avi Loeb and Amir Siraj have done suggest that all the modelling that they've done suggests that, the accelerations and the kind of heating that you get from atmospheric friction, that these microbes could survive all those things. And they also calculate that over the lifetime of the Earth, they say between 1 and 10 comets and between 1 and 50 interstellar objects have come close enough to graze the atmosphere. So it has happened. Whether they collected microbes or not is a different story.
Yeah, as long as they paid their fare, I would imagine they got where they were going. I would take the argument a bit further and say it's probably both. We are we are seeding other areas potentially, and other places are seeding us. Or
It could well be. That's right. I have to say that the panspermia theory, which is what this is called, the idea that life came to Earth from elsewhere, is still not really regarded as mainstream science, although the paper last year had some very, very compelling arguments in it, some really good articles online about it. Just essentially Google Chandra Wickramasinghe and it'll take you straight to them.
It's definitely a good discussion point at the water cooler at Geek Central.
Yes, I'm sure that's right.
They have a head office in New York, apparently. But it's one that just gets your tongue wagging. It's just one of those things that we can't prove either way, but it had to happen somehow, and all we've got's theory.
That's right. But one thing we do know is we've had Oumuamua, this is what you call the space doogie. That's right. And
you've got to get it out there. It's going to become the common name.
I think you've already done it, actually. Comet Borisov, the one that's still in the solar system. These are two objects that have come from other solar systems and are just whizzing through. So we know those events happen. The seeds are being laid, if I can put it that way, for perhaps a revolution in our understanding of where life came from.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. SpaceX has launched its fourth batch of 60 Starlink satellites. The mission had been delayed by 2 days due to bad weather, both at the launch pad and at the booster recovery site. The Falcon 9 rocket blasted off from Space Launch Complex 40 at Cape Canaveral, successfully deploying the satellites an hour later. The core stage returned safely to Earth, landing on the drone ship Of Course I Still Love You, which had been pre-positioned downrange in the North Atlantic Ocean.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Vehicles pitching downrange.
Stage 1 propulsion is nominal.
And we've just had a nominal liftoff of our Falcon 9 vehicle carrying our Starlink payload on its way to its targeted orbit. In just about 20 seconds coming up here, we will be passing through max Q.
Falcon 9 is supersonic.
That is the maximum aerodynamic pressure that the vehicle will see, which is the largest structural load that the vehicle sees throughout ascent.
Vehicle is experiencing maximum aerodynamic pressure.
And we've just heard that call out from Max Q. Coming up next will be 3 events back to back, starting off with MECO, or main engine cutoff, followed immediately by stage separation, and this is where the first stage separates from the second stage, and then followed by SES-1, which is second engine startup.
And back engine chill.
There's that main engine cutoff.
Engine cutoff.
Stage separation confirmed.
Let's see the stage separation. First stage separating from second stage, second engine startup. That's that MVAC engine on our second stage. So now coming up in about 20 seconds is fairing deploy. We will be attempting to catch both payload fairing halves on our recovery vessels, Mystery and Mischief.
Fairing separation confirmed.
And there's that call out for fairing separation. Fairing halves are making their way back to Earth, and hopefully we can catch those on our recovery vessels.
AOS Bermuda.
So a lot of really cool stuff coming up all at once or in rapid succession here in the next few minutes. On the stage 1 side of things is at about T plus 6 minutes and 24 seconds. You're going to hear the call out the stage 1 entry burn. That's where we reignite 3 of those Merlin 1D engines, and that allows the first stage to slow down as it re-enters the upper part of the Earth's
atmosphere. Stage 2 is on a nominal trajectory.
Meanwhile, stage 1 is coasting down, getting ready for that entry burn. That burn's going to last just under 20 seconds. After that entry burn, stage 1 will continue to coast down towards the drone ship, and at about T plus 8 minutes or so, you're going to hear the call out for the landing burn. That is where we reignite a single Merlin 1D engine, that center engine E9, and that slows the vehicle down to 0 velocity. Meanwhile, stage 2 continues to perform nominally, wherein that MVAC is at full power. Now, right after the stage 1 landing, about 20 seconds later, you're going to hear the call out for SECO 1. That's second engine cutoff 1. That is where we cease to burn the second stage engine and takes us into our first coast phase. That stage 2 engine is burning with more than 200,000 pounds of thrust as it takes that stack of 60 Starlink satellites to its first parking orbit.
Stage 1 entry startup.
All right, you see that entry burn as it started? That entry burn was just under 20 seconds long. Meanwhile, stage 2,
Stage 1 entry shutdown.
Stage 2 continues to burn, and we just heard the call out that the entry burn on stage 1 has concluded.
Stage 2 continues on a nominal trajectory.
Stage 1 transonic.
Okay, in just under 15 seconds, stage 1 should start that landing burn. Hopefully
Stage 1 landing startup.
Back. Right, that landing burn is currently going.
Stage 1 landing light deployed.
Stage 2 is in terminal guidance.
Right, and yes. Awesome. That's the third landing of this booster. Second time landing on, of course, I Still Love You.
Falcon 9 has landed. Operators, please proceed.
Very cool. And any second now, we should be seeing SECO 1. That is where that second stage engine will cut off.
Back shutdown.
All right. As you just heard, second engine shut down.
LOS Cape expected.
And we got confirmation that we're in a good orbit.
This mission takes the number of Starlink satellites now in orbit to 182. Previous Starlink missions have included 2 test satellites launched in 2018, followed by 3 launches each carrying 60 satellites in May and November 2019 and in early January this year. SpaceX hopes to have 12,000 of the 227-kilogram dinner plate-sized satellites deployed by the mid-2020s. The company's long-term plans are to have some 42,000 satellites in the constellation, with initial spacecraft being placed in 550-kilometre high orbits and later deployments targeting orbits as high as 1,325 kilometres and as low as 335.9 kilometres. SpaceX is trying to beat several other competitors, including OneWeb, Amazon and Telsat, to commission its new high-speed broadband internet satellite service. This mission was also the third flight for the same Falcon 9 core stage, which had previously launched the Crew Dragon 2 capsule on its successful first demonstration flight to the International Space Station last March, followed by the RadarSat Constellation mission in June. And time now to take a brief look at some more of the other stories making news in science this week with a science report. A new study has found an association between people who consume more fermented soy products like miso and natto and a lower mortality rate. However, the findings, reported in the British Medical Journal, have shown no such association for non-fermented soy products like tofu and soy milk. The authors warned that while there were nearly 93,000 participants in the study, their findings should still be treated with caution. That's because they couldn't control for factors like socioeconomic status, certain diseases, and the possibility that the people who eat fermented soy products also eat more fruit and vegetables. A new study claims kids' rice snacks found in Australian supermarkets contain arsenic levels above European safety guidelines. Scientists found that 75% of rice-based products tested had concentrations of arsenic that exceeded EU guidelines for safe rice consumption for babies and toddlers. You can read the study in full in the International Journal of Environmental Research and Public Health. Well, every Australian knows to slip, slop, slap sunscreens over themselves to protect from dangerous UV rays from the sun. But a new study reported in the Journal of the American Medical Association warns that sunscreen chemicals are being absorbed through the skin and making their way into the bloodstream. The findings show that the levels of active ingredients being absorbed exceeds US Food and Drug Administration thresholds. Scientists tested 6 of the main active ingredients in lotions, sprays and pump varieties of sunscreens, finding the quantities of active ingredients discovered in the blood would mean the FDA will require additional safety studies. The authors say the findings don't mean people should stop using sunscreens, but that more research is needed to figure out the significance of these levels in human blood. These findings follow recent studies showing significant levels of microplastics or microbeads were found in sunscreens as well as cosmetics and toiletries. And these microbeads and microplastics were ending up polluting the environment and oceans. Chinese scientists have designed a coating that could be used on cell phones to help keep them cool on hot days in the same way people do, by sweating. Now, it all sounds pretty gross, but the phone's sweat would be simple water vapour, so hopefully it'd be considerably less offensive than human BO. A report in the journal Jewel claims the new sweaty system could prevent overheating without the need for bulky, energy-hungry fans. And it could replace the inefficient waxes and fatty acids manufacturers currently use to keep devices cool. The researchers claim their sweat phone would be 10 times more efficient and will use metal organic frameworks capable of storing large amounts of water, making them heat sinks. Scientists have released the Kraken. Well, at least the Kraken's genetic code. The giant squid, Architeuthis dux, has been the stuff of legend for centuries. The infamous sea monster lurking down in the abyss, and then striking suddenly without warning, snatching sailors from their ships and dragging them down into the deep dark. The giant squid usually resides at depths of around 1,200 metres, they're rarely ever sighted, and have never been caught and kept alive for long. Mind you, a few have been caught in fishing nets or washed up on beaches. The 10-armed cephalopods are known to reach lengths of 13 metres and weights of more than 900 kilograms. But little else is known about them. Their biology, even how they reproduce, is still largely a mystery. One of the problems has been getting good quality DNA. Available samples have originated from decomposing squid with elevated levels of ammonia and preserved in formalin or ethanol, and that's meant poor genetic DNA sequencing. And that's where the new samples come in. Analysed by researchers from the University of Copenhagen, they came from freshly frozen tissue collected by a fishing vessel near New Zealand. By sequencing and noting their genome, scientists hope to unlock some of the giant squid's secrets, such as its growth rate, its age, and how it gets to be so scarily big. Scientists have discovered that the giant squid's genome has an estimated 2.7 billion DNA pairs. That's about 90% the size of the human genome. While cephalopods have many complex and elaborate features, they've evolved completely independently of vertebrates. So, by comparing their genomes, scientists can explore whether cephalopods and vertebrates are built the same way or differently. Well, we know she can't budget for a family. She's not much good at photoshopping herself to blend away those age-related crow's feet. She only got into show business thanks to her family connections. And, oh yeah, she sells pseudoscientific products as alternative health and wellness treatments. I am, of course, referring to sometime actress and full-time woo entrepreneur Gwyneth Paltrow, who has a new series on Netflix based around the products and services she sells through her Goop outlets. Goop, and by extension Paltrow, have drawn massive criticism over the years by showcasing expensive products and promoting medically and scientifically impossible treatments, many of which have harmful consequences. In fact, Paltrow was recently forced to agree to pay $145,000 in a consumer protection lawsuit settlement and refund her customers over unproven claims about the so-called health benefits of inserting egg-shaped stones into the vagina, allegedly to cultivate sexual energy, clear chi pathways in the body, intensify femininity, and invigorate life force. Now, all that came after her Goop website was slammed by doctors and medical health experts for recommending that women steam clean their vaginas for extra energy, to rebalance female hormones, and for a squeaky clean uterus. Then there's Paltrow's dangerous coffee enema device, and her vagina candles. It's all very strange. Tim Mendham from Australian Skeptics says Paltrow's lifestyle website is infamous for recommending treatments that are later debunked. And Australian skeptics are concerned that Netflix is now promoting it.
Lovely Gwyneth has been around for a number of years now promoting the Goop label and the Goop shops and that sort of thing. Internal cleansing products, jade eggs to be inserted to add to health, etc. Highly dubious, highly dangerous. All sorts of different things, all the way to psychic cures and people talking to the dead, etc. Runs the whole gamut, mainly alternative medicine, quack medicine, definitely. And now Netflix is putting on a limited series, I think it's about a 6-episode series, called The Goop Lab, which is basically promoting everything that she's been talking about. And it's pretty upsetting to see that Netflix is blindly promoting this sort of nonsense, which is dangerous.
It's been very popular in the States, Goop. What does that say about people when they're prepared to buy these products, even though there's absolutely no medical evidence that they work? And in fact, the evidence is some of them are actually dangerous, very dangerous.
I think part of the issue is it's actually Gwyneth and the way these products are presented. Very sexy-looking packaging, very sort of classy-looking promotion, etc. Gwyneth herself is an attractive person. It's not like some seedy person selling stuff down the road, in a dodgy shop. This is highly professional promotion. And obviously there's a lot of people out there who have more money than sense and are happy to then pick it up. Whether it's disposable income that they want to sort of spend, whether it's a fun thing, whether it's a glamorous thing or whatever, it does say a lot about the people who completely forego any sense of sort of reason and logic and looking at the evidence in favour of something that is goop. Even the name is sort of designed to be fun.
Does Paltrow believe in this stuff? Or just the money?
Certainly the money. She has said at times that she doesn't know what these things are, or at least some of them.
So she's willing to put her name behind something that she admits she doesn't understand.
Yeah, it wouldn't be the first person to do that, really. It's just celebrity promotion, and celebrity obviously has some sort of authority for God knows what reason.
Yeah, well, we see them involved in politics all the time these days as well, and quite frankly, I can't imagine anyone I trust less to understand world affairs than a celebrity.
Absolutely. I mean, what is the criteria used to support their views? None. They're famous. That's it. But I mean, even people who are in the field of sort of promoting alternative medicine, the person who was head of the Australian Anti-Vaccination Network, her qualification, as she said herself, was she has a brain, and that was it. Authority and qualifications seem to weigh for very little compared to glamour and glitz.
That's Tim Mindham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.